the key thing about cellular, and Verizon just mentioned it in a previous session, it's right now, it's here. They have a network deployed. This is just an evolution of LTE. So we believe that cellular and IoT is here, not just here today, but continuing to evolve. Some key things. A lot of times you'll see charts showing how fast things are. And LTE is on, if you go to the left, it's going faster. And in the past, we've kind of, as 3GPP or a standards organization or an industry, have maybe not focused on IoT. We've repurposed things that were enabling, let's say, cellular broadband devices or mobile devices, your cell phones or other things, repurposing them for IoT. What 3GPP has done recently, over the last year and a half, very aggressively this past year, is focused on scaling down, not just scaling up. We've announced, gigabit solutions. We have gigabit solutions, but now the intent is to focus on optimizing power, optimizing cost, focusing on narrowband technologies. So instead of just scaling up faster, it's scaling down as IoT needs it. And that's one of the reasons with 3GPP scaling down, it uniquely positions the LTE IoT with the narrowband technologies, Cat M1 and NB1, which we talked about which I showed on the previous slide, didn't talk about it, to compete with the other low power wide area solutions out there today, from the likes of Sigfox or LoRa or Ngenue. The reality is the cellular will not only compete here, but is better positioned. It's offers you ubiquitous coverage. It's backed by global standards. It's backed by carriers worldwide, and the deployments. I mean, there's more than 1 billion connections today on LTE and 500 networks deployed worldwide. So it'll be a quick transition, and not to say that the other guys won't find niche applications, but certainly cellular will own this. It's a mature ecosystem, ubiquitous coverage. It's scalable. There's things that people care about. Security. The carriers have already figured this out. The government trusts them. Agencies trust them. So they should be able to be trusted with IoT applications also. Maybe more so than some people floating around in free space. As we move into the path to 5G, and this is just kind of a visual to show that LTE is going to continue to evolve. You'll hear a lot of marketing, especially as we go into the 2018 Olympics. You'll see a lot of marketing around 5G. So what we see is EMTC, which is introduced. I think Verizon said they'll have mass deployment in Q1. I'll keep quoting them from one room over, and take credit for it. But you'll have M1 deployments next year in mass. You'll have moving into narrowband IoT. Each of these scales down to address specific use cases. NB IoT scales down even more to allow for delay tolerant solutions. And actually the NB1, when we get to NB1, it's actually acting as the baseline for 5G, narrowband 5G specifically, because 5G, which I will get into in a little bit, has a bunch of different variations. It's not just narrowband IoT or low data throughputs. It's more of a configurable network. But bottom line, what's being done today in 4G as an evolution of LTE going to narrowband will serve as the baseline to 5G. All right, so new narrowband technologies. You've heard this. 3GPP coming in with Cat M1 and NB1 are to specifically address to cost is one that's better known as reduced complexity. People translate that as cost. Multi-year battery life. You're talking about measuring battery life in years, not days. There's some techniques we'll go over in a few minutes that actually enable that. There's also techniques for deeper coverage. So in building, in ground, maybe underground parking garages. So things that typically have issues. There's a 20 up to a 20 dB link budget gain as you move to these narrowband technologies, which will enable use cases which maybe would have to have been addressed with a separate proprietary network, then maybe meshing back to a gateway. That cellular will now have direct ability to do. And higher node density. We know to get to 5 billion devices, a lot of things are going to have to get connected. and it's not like the surface area of the Earth is growing. Those devices are going to get deployed more densely. So that's kind of, as you move into narrowband, what LTE IoT, narrowband specifically does, reduces complexity on the radio. It has some techniques to allow for multi-year battery life, and then deeper coverage and higher density. One of the techniques for delivering multi-year battery life is power save mode, PSM. That is more focused for devices that are mobile originated. So your device wants to wake up and transmit something versus a device that's constantly listening. So extended DRX is something that is intended for someone that needs to be connected and be paged by the network, so mobile terminated device actions versus power save mode. So power save mode is doing some interesting things. It can basically sleep as long as it would like to. I think there are some limitations, but it stays registered on the network, so it's more efficient when it comes back on. It's not like you're shutting yourself down, re-registering, coming back up. These techniques allow, like I said, for mobile originated messages, so your device paging the network, to be much more efficient with power save. So these two techniques in particular extend battery life, and that's the intent. Okay, so this is kind of a stack up. Where we are with Cat 1, I talked about extended coverage. Cat 1 is the baseline. Cat M1, which will be introduced this year, introduced, I guess, the beginning of next year, maybe announced this year, have done some techniques, and NB1 have done some techniques with redundant transmissions, either through repetitive natures or bundling and repeating things inside a particular frame. And basically, by moving to narrowband, they've effectively, their power density is up. And as you go into NB1, there are some additional things that go on with lower order modulations schemes and relaxed requirements and timing, but also the option for single tone uplink. So basically, instead of putting all of your transmissions into multiple tones, you can condense your power into a single tone, thus getting you additional coverage. So these are some of the techniques that lead to that 20 dB. And right now, that 164 is in alignment with anyone who is deploying non-standardized solutions, like Sigfox or LoRa, very similar to what their link budgets are. And so if you look at that, cellular now has an option to narrowband and from a coverage perspective. One key thing with NB1 and M1 is they can coexist. They're an evolution of LTE. They are part of release 13. They'll continue to evolve in release 14. They can coexist with the existing cellular networks. So thanks to Verizon spending their billions of dollars and AT&T spending billions of dollars, and everyone spending their billions per year on their LTE networks, with a software upgrade or potentially some core network changes, depending on the technology, you now can leverage your existing resources. Cat M1 can operate anywhere in band. Cat NB1 has the opportunity to go in band, operate in guard band, or standalone. It depends on the deployment. So it's a more flexible deployment model as we move forward. Okay, and then there's some things on the network optimizations. So there have been made some changes on the signaling side. They're simplifying the core. It doesn't mean you have to update your core network to do narrowband IoT or Cat M1, but it certainly it gives an evolution of core network to take some of your network elements and combine them and make a more efficient use of your resources. And then obviously resource management. There's a few things where they can now, techniques by which you can address a large number of devices all at the same time. And so all of these happening on the operator side allows the more efficient use of the network resources. Now, quick transition into 5G and beyond. So, say 5G and beyond, and then we talk right back about the narrowband stuff. So release 13 will continue to evolve. Release 14, there's already work items being put in place to potentially bring in voice, mobility, broadcast capability, and positioning into NB1. Cat M1 obviously supports voice from the beginning as part of release 13, but the intent is to start bringing in some of these characteristics moving forward in narrowband. Once again, this is to set the baseline for what the minimum expectations are when people move to 5G. So 5G. This is what I was talking about earlier, where 5G is considered more of a configurable network. We see things kind of in three categories. There's the massive Internet of Things. That's the things, all the connected devices people are talking about, or what we see narrowband kind of transitioning into. Mission critical. We're talking about things that are ultra high reliability or ultra low latency. They're talking latencies potentially in the millisecond range. So a doctor could remotely be operating on someone. And then you have the enhanced mobile broadband. It's speeds and feeds. It's what you've seen with Cat 12 to date with gigabits. Now this is multiple gigabits per second. So now each of these, obviously, when you start talking about extremes in either direction, cost becomes a big issue. Much lower cost on one side than the other. If you want ultra low latency or multi-gigabit speed, it's not going to be a $5 module that's going to connect to your weather sensor. So but the core network itself will be able to dynamically adjust to these type of scenarios within 5G. So IoT as a whole is not just connecting things producing bits of data. It's connecting everything. And this is kind of a visualization of what that means, from the camera to the medical equipment to anything else. One of the interesting things coming in that will enable massive IoT is the ability for devices to do grant-free uplink. So what it means is that all of the things connected, they don't need to ask permission to talk from the network. They just talk. The network deals with it. Now that asynchronous transmission of uplink, that allows for much more efficient use of the actual network, and the devices to not have to think so much or plan ahead before they talk. This is going to be critical both for things that don't necessarily want to wake up all the time, or things that want to barge in and don't want to wait. So mission critical, you'll see some stuff. Then there's the coverage extension. Now we've all seen this. I think some people highlighted it today. The mesh network. Cellular network ends, mesh network begins, be it 15.4 or Wi-Fi or whatever it may be at the end. One of the things that they're talking about doing is using a single core network to manage multiple technologies. So now that core network will be managing, let's say the 5G network ends and you can then go into multi-hop into, let's say, 4G or Wi-Fi. That same core network will be managing all of those resources. And that's kind of a big thing. When you start getting into massive IoT, these are some things that are necessary for that type of density to exist. This is more, I know this show or this event and a lot of the speakers have been focusing on narrowband IoT and M1 type devices, but this is the opposite of the spectrum. When you get into 5G, these are some of the examples I was mentioning with respect to mission critical or aviation or medical, those type of devices that would require ultra high reliability, low latency, or strong security. And this is just to kind of frame out the whole 5G story. So 5G standardization. This is, it's mentioned a bit. The one thing we wanted to show this visually is 4G will continue to evolve. So if you choose to, I agree with Ken's presentation a couple ago, you need to move to LTE. You need to move to 4G. The other networks are getting shut down. 4G has momentum. It's growing worldwide. Now, the good news about 4G is it will continue to evolve. It will continue to be part of the massive Internet of Things, the Internet of Things with 5G. Kind of the key thing, the initial release, as with all releases of 3GPP, it's going to focus on an enhanced mobile broadband experience. You're going to hear people talking about millimeter wave and super fast throughputs, but that's the initial focus. That's the sexy stuff. That's where people are going to go first, and then they go into mission critical, the techniques to get ultra low latency and high reliability. Now, that doesn't mean they're ignoring massive IoT. It just means massive IoT comes most likely in phase 2. And if you look at the timeline, it's out there. So not only does 4G standalone have legs, but 4G will continue to evolve as these new technologies get introduced. That's kind of the intent of this slide, to visually show 4G and LTE continuing to evolve. Now a little bit to get to say what Qualcomm, where we fit into the picture. So we believe Qualcomm is uniquely positioned to address IoT. This is, we're one of the few people that have a portfolio, I think maybe the only company that has a portfolio this broad. You know, if it's PLC or Bluetooth or Wi-Fi or cellular, you know, we have it. We have a solution. We have, not only do we have the connectivity stuff that everyone's always talking about, but our heritage is their phones. It's smartphones. It's what you're carrying in your pocket. It's the amount of processing you're carrying on your person. As Internet of Things happens, as the edge continues to expand or evolves, it's not always going to be a cloud problem. It's great to have cloud connectivity. Cloud won't go away. But to solve all of your problems in the cloud may not be the most efficient thing. So we believe that at the edge, there will be a heavier compute burden, maybe some local decision making, maybe some rules that get pushed out to the edge so you know how those devices behave, or maybe it's all exception-based reporting back through cellular, just to make sure it's efficient. But as that compute at the edge continues to evolve, the need for it, we're uniquely positioned there also. We have as much processing as you could possibly handle in your phone. We certainly can do it on the edge and repurpose that for IoT. And that's our intent. Focus in on the connectivity, focus in on the compute. I keep mentioning over and over and over. So when you get up to our fancy fiber-like experience, gigabit per second, X16 LTE module, see they have really cool names, they have X's. When you come down here in the not so sexy part of our roadmap, but it's the one that I think will drive the majority of the volume and truly connect the Internet of Things and make cellular relevant for Internet of Things. That's our Cat M1 and NB1 solution. It's called the 9206. We announced that I think over a year ago, or right around a year ago. We announced our intent to do this chip. And that's kind of the key thing. We're scaling up and scaling down. We're not only driving standards, but we're also driving the commercialization of those standards on both ends. That said, I'll focus in on 9206 a little bit. I'll come back down to earth. But so some of the things, as I just mentioned, we were leaders in 3GPP for 4G, for standards. We're going to continue to be leaders in 5G. We're one of the main contributors in each of those. With the 9206, our narrowband, our Cat M1 and narrowband solution, it's a single chip designed to do both Cat M1 and NB1. With the simplified architecture of the device, we're able to get rid of all of the band-specific components. So it's truly one piece of hardware that can work worldwide. Now, it may require a different software version, but if you're doing SKU management, it's a single piece of hardware that can be used on any networks, any operator in the world with the right certifications and software. But that's key, because right now, when you want to deploy something on Verizon versus AT&T versus Vodafone, there's different duplexers and diplexers and SAW filters, acoustic filters. And with our implementation on our 9206 device, you can get rid of all the band-specific components. So that's going to be one thing that we see as key to adoption in a broad form. And then, so like I said, it's one hardware, one RF. Now I think you've seen some announcements. I just wanted to thank Telit for having us here and allowing us to be here. But we've had a long-standing relationship with Telit. We're in a lot of the solutions, not all. We'd like to be in all, but we're in a lot of the solutions they use. And we are going to be in their 910 form factor for Cat M1, and we're already in there. We're already planned or in development with our Cat 1 solution with our 9207 based design. And those are both purpose-built for IoT. The 9207 and subsequent 9206 were the first time we as Qualcomm did a chip for machine-to-machine, which has now been renamed IoT. In previous lives, we always took mobile broadband chips and kind of squeezed them into those applications. But these are purpose-built. It still has application processors on board. You may or may not see that implemented, but it certainly has the capability for local applications. And then it's kind of the key, and now jumping back into 5G. So we're leading in that technology. We're influencing standards very heavily. We are taking a system-level approach. We've done some pretty ingenious demonstrations. Our intent is not just to commercialize a chip. Our intent is to commercialize a solution, influence all aspects of it, and make people think about what 5G is, what the core network is, how these things are going to interact. So we take a holistic system-level approach to not just the prototypes, but also the implementation. And then obviously as 5G happens, as 4G continues to evolve, our global scale is unmatched. We certainly have scale thanks to smartphones, and we're taking that scale into IoT. So in summary, we're excited. Qualcomm is excited about IoT. We've created a business unit focused on IoT. We're excited about 5G and the opportunities that's going to play long term. But in the near term, IoT is here. Cellular IoT is here. Cat 1 is enabling it, and Cat M1 and NB1 in the 2017 timeframe will certainly provide additional scale and momentum in that space. And I believe put some of the people that maybe got out in front of 3GPP a little bit with their non-standards based solutions, it may throw a little wrench in their works also.